Welcome back to Archviz with Blender and Stable Diffusion. In this lesson, we are going to render Archviz images using WebUI Forge, and in the process, we will learn about the different ControlNet preprocessors. But before starting, let's copy some of the checkpoints we have in our ConfUI installation that Trida did for us. So go into your AI Diffusion, ConfUI models folder and checkpoints. And here we have the 4 saved tensors that it downloaded. So select them and copy and paste them into Forge, WebUI, Models, Stable Diffusion, and paste them here. If you get a file replacement warning, it's because WebUI Forge also downloads realistic vision in the automated process, so you can skip this file. Also, make sure to have the ControlNet files that we downloaded in our ConfUI portable installation. So go to ConfUI, Models, ControlNet, and these are the ones we installed using ConfUI Manager. So these are the ones we're going to be using: Depth, Canny, Line Art, MLSD, and Segmentation, or Seg. Make sure that you have these in your Forge, WebUI Models, ControlNet folder as well. Let's begin by launching WebUI Forge. Double-click on the Run bat file. And once the user interface is loaded into our browser, we can go to the checkpoint section, click on the drop-down, and now you'll see we have 4 checkpoints to use: Realistic Vision, Juggernaut, Flat 2D Animerge, and Dream Shaper. And here we have our VAE file. Let's begin by creating our famous image, a cat in a hat. And in the negative prompt, we're going to use bad quality, worst quality, text, watermark. It's going to be a 512 by 512 image using the realistic vision checkpoint. Click on generate. So now let's try the other checkpoints that we have here very quickly. So let's switch to Dream Shaper. And now let's try Flat 2D Animerge. And here we can notice a difference. That's because Flat 2D is trained to generate cartoon images and anime, hence the difference. And if you go to Civit AI and check the different models, some of them are oriented to photorealism, others are oriented to anime or fantasy. Depending on your needs, you can download a pre-trained model and use it in your Stable Diffusion interface of choice. So let's go back to our WebUI Forge interface, and now let's try the last one, which is Juggernaut Excel, and notice what it's going to happen. If you want to know what's going on the background, click on the command prompt window, and here you can see what's going on behind the scenes. So as you noticed, it was rendering the image okay, and then all of a sudden it became like corrupted. This happens because of something we mentioned in a previous lesson. I first used the 3 SD 1.5 models, and the last one I used is an SDXL model. So remember, we cannot combine SDXL with Stable Diffusion 1.5. Here we have an XL model with an SD 1.5 VAE. And usually SDXL models already have the VA encoder embedded into the checkpoint. So what we need to do here is click on None and generate the image again, since the VAE information is already in the checkpoint. Click on Generate. SDXL is trained on 1024 by 1024 images, so it allows like more definition and resolution and quality, and it's also like faster to generate. Now let's click on Generate again. And you'll notice we are getting a completely different image. That is because of the seed. So the seed is like a noise pattern, and with that noise pattern, it starts like to generate and clean the image out. Right now we have -1, which means it's a random seed number. But if you go to Civet AI, for instance, let's open Realistic Vision and click on one of the images. If you go to the right, you will see the information used to generate this image. So here you can see the prompt, you can see the negative prompt, and other metadata, which is like the guidance, the steps, the sampler used. And here you can see it says seed. So I'm going to copy this value, go back to my WebUI, and replace -1 with this seed number, and I'm going to click on generate again. This seed generated this image. If I click on generate once more, you'll notice we get the same image. So we use a fixed seed number when we need image consistency. If I change this to -1 again and click on generate, it will go back to random images. So now we are ready to start learning and working with ControlNet for Archviz images. So to do that, let's open up Blender and load your 3D model for the course, Final Cabin. And make sure that here on the Render tab, your render engine is set to cycles in case you still have it on Eevee from our last exercise. And in device, make sure you have GPU compute. Well, remember, now you know how to orbit and pan around the scene. I'm going to click on Z, rendered. And I want to show you very quickly that we have an HDRI image in our scene, which provides lighting information as well as background. So if I go back to the camera pressing numpad 0, we're going to render this image and use it for our exercise. So click on Z, go back to solid, and you will notice here in sampling, we have the sampling for the viewport, which is the real-time view here. And underneath that, we have the samples for the final render. So we're going to be rendering 1024 samples. The image size is going to be 1024 by 1024, a square image. To render, remember, you go here to render image, or use the F12 shortcut. So let's click on F12. And in the upper part, you'll notice the sample count. So once it's done, it will run a quick denoise pass, and this is our render image. How fast it renders depends completely on what video card you have and your hardware in your system. Save this image, so click on Image, Save As, and go to your renders folder. I'm going to call this cabin_render. Okay, and now we're going to render a second version of this image. Click on the Render Settings tab, scroll down until the Film tab, and under Film, click on Transparent here. So if you check your viewport in render mode, now you'll see the lighting information is still there, but now the background is going to be an alpha channel. So go back to your camera with numpad 0. And let's click on F12 to render this image again. And we're going to save this image like before. Click on Image, Save As. I'm going to assign it a name, but before doing that, make sure that here, instead of RGB, you select RGBA, which means red, green, blue, and alpha channel. And 16-bit, it's okay. 8-bit is mostly recommended for black and white images like the Death Pass. And I'm going to add cabin_render_alpha. Save it. So now if you go to your project folder, you will have your rendered image, your alpha image, and the Death Pass we generated in Blender, the one we inverted in Krita, and our first generations we did in Krita as well. So now let's change our image size here to the one we have for the render, 1024 by 1024. Let's switch our checkpoint to realistic vision and load your VAE. One of the best things of WebUI Forge is that it's got a lot of things pre-installed, things that in other user interfaces you need to download and install manually. If you go here in the upper part to the extensions tab, all of these come by default in WebUI Forge. So now let's go back to text to image, the first tab, and scroll down and go to ControlNet Integrated. Click on the drop down here, and now click on Enable. And now we are going to create a render based not on our DeathPass image, but on our render. So click on Upload and render your cabin render image, the one that has trees in the background to begin. Click on Pixel Perfect, click on Allow Preview, and from the control type, let's click on Death. Once you click on Death, it will automatically select the preprocessor as Death Midas and the model Death, which is one of the control nets we copied into the folder. If you don't see anything here, make sure to click on the blue refresh button. And if you still don't see anything, unclick Allow Preview, unclick Pixel Perfect, click them again and click on refresh until you get the different models here, and make sure to select Death. So now we're going to use WebUI Forge to generate the death pass for us. To do that, we are going to click on the explosion icon. And here you can see it generated a black and white image. So right click, open a new tab. And it has done a very good job. It's not going to be as precise as a depth map generated directly from your 3D software like Blender or Max or Maya. So right click on the image and click on Save Image As and go to your course folder. In Renders, I'm going to create a folder called ControlNet. And I'm going to save this as Death so that we have a reference of what each of the control types and the preprocessors do. What we're going to do is, using this image as reference, we generated the depth map to force the text prompt to stick to this guidelines. So let's switch our prompt in text to image and type in a cabin in the mountains, comma, blue sky, waterfalls, and leave the negative prompt as it is. Make sure to have Pixel Perfect enabled so that it sticks as much as possible to the Death Pass image. Click on Generate. Very good. So now you can see our render is sticking very close to the Death Pass image, and we are using our Blender 3D render as reference. So now let's change the checkpoint to Dream Shaper and render again. And it's taking a little more time because now we are rendering 1024 by 1024 images using an SD 1.5 model. So that's where the SDXL model renders a little bit faster. This one came out very, very nice. And finally, let's use Flat 2D Animerge. Notice how well it sticks to the guidelines. And there are 3 different images completely. Remember that all of your files are saved in your WebUI Forge, WebUI output folder. And here we have text to image, and they're organized by date. So here are the files we generated today. If you scroll through them, you can notice they are exactly the same image, but changing dramatically according to the checkpoint that's being used. And now if we switch to Juggernaut and we remove the VAE and set it to none and click on Generate, remember that if you want to know what's going on, click on the command prompt and you'll see what's happening in the background. So you will get an error. This error that says type error, non-type object is not iterable. That is because we have an SDXL model, but our ControlNet models are SD 1.5 as well. So always make sure that your workflow is completely tied together. SD 1.5 requires an SD 1.5 checkpoint and SD 1.5 VAE, and control nets need to be SD 1.5. If you go to the ComfyUI version that Krita installed, since we selected all of the ControlNet models, if you go to ComfyUI Models ControlNet, here you'll notice that we have Excel Canny, Excel Dev, Excel Sketch, Excel blah, 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 and all the SD 1.5 models. So should you require to render using an SDXL checkpoint, make sure to copy and paste the SDXL ControlNet models here. But for our exercise, I'm going to stick to the SD 1.5 model. So now we learned how we can generate the depth path from within WebUI Forge and use it to enhance our render. So now let's go to the second ControlNet model, which is Canny. So scroll down again, and now let's change from depth to Canny, and it will automatically load the preprocessor as Canny and the model as Canny as well. And click on the explosion icon. I'm going to right click, open a new tab, and this is what the Canny model does. And it's detecting a lot of detail from the render image. So I'm going to right click and save image as, and I'm going to save this as Canny _01, and I'll show you in a minute why. So with the same prompt and it's changing to Dreamshaper checkpoint, load your VAE file and click on generate. If you notice that it's taking longer than expected, it might be downloading some additional stuff for the models you require since your WebUI Forge installation is new. That's another good thing about WebUI Forge. If anything else is missing, it will download it for us automatically. So now let's check our result here and check how it took into account like all that image in the background. So now I'm going to close this, and I'm going to change my reference image, and I'm going to load my second render, which is the one with the alpha channel. So with a cleaner background, it will allow the AI to be like more creative and generate more stuff for us in the background, instead of having all that noise generated by the Canny model. We are going to click on the explosion icon, right click, open image in new tab, and now you'll see it's even cleaner. This is a very, very good image for reference. So right click, save image as, and I'm going to save this as Canny 02. So it's very important like to be very creative in the way we use our 3D software. One nice resource is to use the alpha channel in it. So now let's click on generate again. And notice how now the background is completely different and the AI is being creative in its own way. So let's try the different models here. Flat 2D, let's do realistic vision. And finally, let's try flat 2D and emerge. Okay, this one came out really nice. Very good. So now let's move on to the next model, which is line art. From the drop-down, select line art, and it will assign the line art preprocessor and the line art model available. We are going to click on the explosion icon, right click, open image in new tab. It's kind of like similar, but I think Canny does like a cleaner job here. So right click, save image as, and let's save this reference as line art because we want to keep a record of what each of the models look like. And let's go back to Dreamshaper, and now let's change cabin for a modern farmhouse in the woods, blue sky, waterfalls. I'm going to add night scene, warm lighting in the windows. Now with the line art image as reference, click on generate. So as you can see, it changed like the architecture type. It switched to a night scene, but it's still tending to be like a winter scene. Let's load again the other render image, the one with information in the background, and generate the line art image again. Click on the explosion tab. I'm going to save this image as lineart02. Click on save and close. And click on generate again. Very nice. Still winter, but very nice. Let's check the images we have rendered today. And this really is like, it's like a trial and error exercise. If possible, try to keep track of what you're changing on each image, what you're doing, so that you find like the set you feel more comfortable with and the set you get better results with. Now let's change Dream Shaper to realistic vision and generate. Good. So now let's move on. I'm not going to do the flat 2D Animerge now, so we can move to our next model, which is MLSD. I will be sharing this glossary in our course files. So MLSD stands for Mobile Line Segment Detection. What it does, it detects only straight lines. So vertical, horizontal, and diagonal lines. It's very good for architecture because of this. But curves will be ignored. It's not going to detect any curves in our image. So this background is not going to be any good for us. So let's remove it. And let's load the alpha version instead. And here we have a lot of straight lines. So now let's switch to MLSD. Make sure the preprocessor and the model correspond to MLSD as well. Click on the explosion tab to generate the preview image. Right-click, open image in new tab. This is like a minimalistic approach, but it's very useful for architecture. I'm going to save image as and save it as MLSD. So let's click on generate. And this is completely different. As you can see, MLSD is one of the most recommended models for architecture. And let's switch to Dream Shaper. Click on generate. Very nice. So far from my own experience, DeathPass and MLSD are the ones that are offering me like best results for architectural rendering. And finally, let's check what Flat 2D Animerge would do here. Very good. Okay, so now we're familiar with 4, and now let's check the final checkpoint, which is segmentation or seg. This is segmentation. So what it does, it's like it assigns a specific color to each of the objects it detects in the scene. And according to the color it assigns, it makes the control of the image possible. So let's switch to our final checkpoint, which is segmentation. Here it would load seg as preprocessor and seg as the model, and click on the explosion tab. Right-click, open a new tab, and as you can see, it detected like the bigger masses in the 3D render scene. So right-click, save image as, segmentation, or just seg. So now if we go to our folder, we have the different ControlNet images that we are learning in this lesson. And now we know what each of them does. And now we know how they help us on the final rendering image. I'm going to go back to Dream Shaper and click on Generate. This one came out like a little crazy because it doesn't have as much detail as the other checkpoints we generated. So you can see here, it's only one color, so it doesn't have any information to generate. But I think it's doing its best job at generating the image we are creating. So let's switch to realistic vision and see what happens. So it's also a good result, but there's some information missing here. The previous image even looked like a section plane in a 3D software. And let's finish by using Flat 2D Animerge, and let's see what this checkpoint interprets of this segmentation image. So even with the lack of information, I think it's generating some amazing images. The most important thing for me is that these images become like a source of inspiration for the project you are creating. These might not work as final renders, but they can help you show your client different options, and then he can decide the different kind of look or materials or lighting, and it will streamline your work and help you to head where the client wants you to go. So I think that is the important usage we have to do of any AI these days. So now if we check the images we generated, I want to analyze which of these we can generate directly from our 3D software. The depth paths we can generate it in Blender very nicely using Eevee and the inversion trick. Line art, I didn't think it was like very useful. MLSD was quite useful, and this can be generated in Blender using grease pencil, but it's also a little complicated. Canny, it's a little similar to MLSD, but I think MLSD does a very good job directly from within the WebUI Forge. And the final one, Seg, this kind of image is called a Cryptomat. So Cryptomat is an open source automated ID mat generator created by Jonah Friedman and Andy Jones. Now you can implement it in any 3D software, and by doing so, you are able to identify each and every one of the objects in your scene and assign it a color. Here you will find the different tutorials for each of the different 3D programs. I will be sharing this link as well, but there are other solutions that make the job easier for us. For instance, if you go to Blender Market and type in CID, search, CID stands for Color IDs. This is a plugin that automates the process for us. It's not free, but it's not expensive either. So very quickly, I'm going to show you here in the render view. I'm going to click on N, and N will open and close this side panel tab. And here you'll see there is a CID tab. It's got 3 steps. Number 1, decide if you want to use the object or the material path. So I'm going to use the object path and enable nodes. Now, number 2, decide if you want to build the materials or the objects. I'm going to build objects. And finally, create your material ID or your object ID. I'm going to go with create object ID. And we are going to render the scene now. So apparently nothing changed, but that's because we need to go to the Blender's compositor. So here in the upper part, you see different tabs: modeling, sculpting, UV editing. Go to the one that says compositing, and here it is. This plugin does all the hard work for us, and all you gotta do is save this image and use it as your segmentation map. By sliding the different colors, you will change the color IDs in your file in real time. So when you're ready, click on F11 to check your last render, and from the drop down, look for node, and you'll see viewer node. Click on that, then go to image, save as image, and we are going to save this one as cabin render seg. Now I can close Blender. So if we compare the seg generated by WebUI Forge to the one in our 3D software, obviously you'll see that you have a lot more control in your 3D software. So whenever possible, try to create the reference ControlNet images from your 3D software. Otherwise, use the default algorithms that come with the artificial intelligence. Okay, so now that we're done with the text to image section using the generated ControlNet images from within WebUI Forge, we are going to learn how to do it in the image to image using our rendered images for ControlNet. So change to the image to image tab. And now we're going to use our render as reference. So click to upload. I'm going to use the alpha version here. And if you scroll down, you can change the image size. Or here we have a new icon, which is this ruler. Click on it and it will auto detect the image size for us. And now let's go to the ControlNet section. The workflow is going to be very similar to the one in text to image. Click on ControlNet, click on enable. Make sure to select Pixel Perfect. We are going to select Depth and make sure it selects your preprocessor and your model for depth. But now we're going to upload an independent control image. So click on this. Once you click this, you will have the option to load a separate image. So this is where we're going to load our depth path, the one we generated with Blender and then in Krita. Now we will have a lot more definition in the ControlNet for the output of the render. Before doing that, make sure the preprocessor, we don't need it because we are already providing the image. So in preprocessor, click on none. And now let's get our prompts from our text to image tab. So select everything here, copy, image to image, paste, negative prompt, copy, and paste. Let's begin with Dream Shaper and everything is ready. So click on generate. So now if you check the result, you'll notice that it's a lot more detailed than the results we had in text to image because both the reference image and the ControlNet image have a lot of information, a lot of detail. Not like the case here that we have a very good reference image, but the ControlNet image doesn't have as much information. It all depends on your needs. You will not always have access to the 3D model. Maybe they will just give you the photo of a project. So if you only have the photo of a project, you'll be forced to generate the ControlNet images from within your AI software. But in this case, now that we have the 3D model, whenever we have the chance to generate the ControlNet images, we can do that. Let's change to realistic vision and generate. So this is the result. And finally, let's try out flat 2D and emerge. Generate. Very good. The other image we can use is the segmentation file. I'm going to change the prompt a little bit. A modern farmhouse by the beach, palm trees, blue sky. So let's go down. The reference image is going to be the same. I'm going to change the ControlNet to segmentation. Remember, pixel perfect, upload independent control image. So here we're going to close, and now we're going to load the segmentation file, which is our CryptoMat or object ID file. And remember, in preprocessor, select none because we are already feeding the ControlNet image to the software. And click on generate, but I'm going to begin again with Dream Shaper. There we go. And finally, let's change to realistic vision. Very nice. So as you can see, segmentation offers even a lot more detail than any other model because the object ID image has got a reference for each and every of the objects that the 3D software detects. And I'm going to run a final pass with flat 2D and emerge. Very nice. So that pretty much concludes our lesson. And I want to congratulate you guys for getting this far in the course. And things are going to keep on getting more interesting as we head to the final part of the course. Now, my conclusion for this lesson, the ones that I tend to use the most are the ones that I can generate from a 3D software. I tend to use more the depth pass and the segmentation pass. But I kind of like a lot the MLSD result you get even from within WebUI Forge. So in the next lesson, we are going to try to do the same we did in this lesson, but with Comfy UI, and you will notice the difference in the workflow. So congratulations again, and see you on the next lesson. Bye.